Okay. So suppose f is the differentiable function of x and y, and a function g of u and v is equal to the function f of u and v. And so given the table of values, you want to find the derivative of g with respect to u at the point 0, 0, and find the derivative of g with respect to v at the point 0, 0. And so we're going to be making use of the chain rule. And how we're going to do that is we're going to note the fact that the derivative of g, these are partial derivatives, the derivative of g with respect to u is going to be the derivative of g with respect to x multiplied by dx over du. Okay, and so what we're going to do is we are going to set g u v is equal to a function of x and y. We're going to set x is equal to e to the u plus sine v, y is equal to e to the u plus cos v. And so when I say that I want g of x, this derivative, since g is in terms of u and v, this technically doesn't make sense. So what instead I'm going to write is f of x with respect to x and y. So they're the same function. Instead though, here I have terms in terms of u and v. Here I'll have terms in the sense of x and y, but that x and y themselves will have terms in terms of u and v. And so now what is going to happen is you'll have dg over du is equal to, instead of the derivative with respect to x, we'll write it in this form. So fx at x, y, multiplied by dx over du, plus fy at x, y, multiplied by dy over du. And now, additionally, we want this evaluated at 0, 0. Which means we will evaluate the partial derivatives at 0, 0, multiplied by dx over du at 0, 0. Dx over du will become eu plus cos v, and at 0, 0 that will become 1 plus 1. Alright, just one moment. So 2. Additionally, this one will become EU minus sine v, and that will just become 1 minus 0, so 1. So dx over du evaluated at 0 is going to be 2. Plus the derivative with respect to y at 0, 0, multiplied by dy over du at that point, so by 1. And then luckily we have been given fx and fy at these various points. So fx at 0, 0 is going to be 4, and fy at 0, 0 is going to be 8. Oh, but please note, I've made a mistake here that people are prone to making, and that is the fact that we want gu 0, 0, and gu is in terms of u and v, which means we're setting u and v equal to 0, not x and y. That's where the mistake has occurred. And so what that means is if u and v are equal to 0, x is 2 and y is 1. And so instead of fx 0, 0, we'll have fx 2, 1 here. And similarly here, again, we'll have fx 2, 1, because we have the x values in here, not the u values. And so now when you come and look at the table again, fx at 1, 2 is 2. So it becomes 2 by 2, plus fy at 2, 1 is 5. So 5 by 1, and that will become 4 plus 5, which is 9. Sorry, I'm just ensuring everything makes sense here. E0. And that's going to be your final answer. Next up, we're going to do the same thing, but with respect to V. And so just remember, and so we know that this is fx, and we're going to be evaluating it at u is equal to 0 and v is equal to 0. And this one is going to be fy evaluated at those same points. And so we have stated that x is equal to e to the u plus sine v. So x at that point, at the point 0, 0, is going to be equal to 1 plus 0, so 1. Y is going to be equal to and I think the same mistake occurred above. Sorry, so this should be f12 and 12 because I'm not putting in the derivative of x at 0, 0. I'm putting in x at 0, 0. And so this should also be f of 1, 2, f of 1, 2, and this should give you fx at 1, 2 is 2 by 2 plus fy at 1, 2, which is 8 by 1. 5 by 1, my apologies. Let me just ensure everything else is okay. This evaluated at 0, 0 is going to give us 2, and this is going to give us 1. And so this should give us a final answer of 9. It gets a little tricky because of how many different functions you're using, and you can slip up with the terms as I did before. It just matters that you go through things and catch those mistakes before you submit your work. And so lastly, we have dx over dv is going to be equal to, see, similar here, we have the same mistake that I made. The derivative with respect to u is just going to be e to the u for both of them. And so this is going to be equal to 1, this is going to be equal to 1. So we are going to be multiplying both of these by 1, and instead it should give the answer 2 by 1 plus 5 by 1, which is 7. And that's the correct final answer. So dx over du evaluated at 0, 0 is, over dv is going to be equal to cos v, and evaluated at 0, 0, that's going to be 1. dy over du evaluated at 0, 0 is going to be negative sine v. This is v, and that's going to be negative 0. And so now when we put that all together in this formula, we will have dg over dv evaluated at 0, 0 is going to be equal to f of x evaluated at 1, 2 multiplied by dx over dv at that point, we know that that's 1, plus the derivative with respect to y evaluated at 1, 2, multiplied by 0. And that is going to give us 2 by 1 plus 5 by 0, just leaving us with 2. And that's going to be your final answer for this one.